In this example, I'm going to do binary search. I'm going to use C again, and I'm going to use insertion sort code from a previous example because the arrays in a binary search algorithm must be sorted. So starting here, we're going to have this array. It's clearly not sorted. We have the length value because this is written in C, and then a print array function, which will just do a sanity check. I'll just print out the values of the array so we can see it. Perform the insertion sort print, and then here's the interesting parts. We have the binary search algorithm. The binary search algorithm works by having the sides of the array. So every iteration through the array, we cut it in half, and we check our key value, our find value. If it's the value we're looking for, then we return the indice. If it's not, then we cut the array size in half again, and so forth until we essentially until we iterate out of the indices of the array. And if we do that, then we return -1. So that's what I have set up right here. And I'm going to run this really quick. Regardless of what we're searching for, it's not going to work. So gcc wall. And make sure this compiles. And 13 was not found because there's nothing set up at the moment. I also have a counter variable set up so we can track the number of iterations going on, which will be interesting, I think, once I go over the example. So the way binary search works is it starts with a low value and a high value. Since the array is sorted, you don't have to start at 0 or the end of the array. You could start anywhere, but for this example, I'll start at 0 and the end of the array. Now, keep in mind that the arrays are 0 indexed, so when you calculate the length of the array and you get the high value, make sure you do length -1. Start at 0 and high equals length -1. Don't do length in C because you'll index outside and you'll get an error. And the next thing we need to do is iterate. We want to go from low to high. We're going to be changing the low and high values depending on whether or not we find our value that we're looking for. In this case, we're looking for 13. So the way this looks is we get an average of the array. We cut it in half, we get an average, and then we compare the array value of that middle indice with low and high. And if we find it, then we return the middle indice. If not, then we modify low or high using the middle indice, and we continually cut the array size in half until we either find what we're looking for or we don't. So we'll start with the middle. And since low and high are both integers, this will be an integer division. So for this first iteration, we start with low equals 0 and high equals 5. Length right here is 6. So we pass in 6 right there. And then we obviously don't want to index outside the array bound, so we'll start at 5. So 0 plus 5 is obviously 5 divided by 2 will be 2, integer division. So that's our middle value. So 2 becomes 0, 1, 2, which is 5. And we're looking for 13. So 5 is obviously much less than 13. So we need to bump up the low value because it's less than the find value. If we index higher, then we would decrement the high value. I'll show you that down here. So let's first see if we found what we're looking for. Array middle equals find return middle. In this case, we didn't. And let's see. Actually, I'll worry about that in a second. And else if array middle is less than find. So this is this example where the middle value ends up being 5, or the array value with the second indice 0, 1, 2 is 5. It's less than 13. So here we bump up low. Low equals middle plus 1. In another situation, well, this will end up being, let's see, low now equals 2 plus 1, which is 3. If we indexed higher, we would be array middle greater than find. High equals middle minus 1. And I'll show that in a different example. And that's really it. So now low is equal to 3. High is still equal to 5. So we get a new average. 5 plus 3 is 8 divided by 2 is 4. Simple math. And the middle value, so 0, 1, 2, 3, 4 is 9. We're still lower than 13, so we hit this again. 9 is less than our find value, which is 13. So low is now middle plus 1. 4 plus 1 is 5. And high is still going to be 5. We didn't change that. And in this iteration, we now have a new middle. 5 plus 5 is 10 divided by 2 is equal to 5. Simple math. and the middle indice is now 0, 1, 2, 3, 4, 5, 13. So we hit this condition. The array of middle is 13, which is equal to our find value, and we should return it here, and that should be our third iteration. So I have this counter variable up here, and I want to show you, and that will increment every iteration. So it starts at 0, so we won't count the 0 value. So this should be the third iteration. So we go down here, binary search. Let's see. Let's compile that. Okay, looks good. And we should get that it was correctly found on the third iteration. Number of iterations 3. Index found 13 at index equals 5. Number of iterations equal 3. Right. And just really quick, let's do. This should come out, I think, after 4 iterations, maybe. Let's look for 100, which obviously isn't in the array. It should be, I think, 4 iterations. Oh, well, I didn't count the counter variable. Let's check that really quick. Counter equals %d. Okay, still 3 iterations. Well, whatever. And that's basically binary search.